Okay, let's go ahead and get started. Today we'll be talking about how to bring a game that you made in Unity to Xbox One and how to really take advantage of everything the console has to offer. My name is Charles Sanglim-Suwan. I work in developer relations at Unity, and part of my job is to focus on helping developers, such as yourselves, push your games to achieve your target performance goals. Standing next to me is Alexandru Marion, a good friend and colleague coming all the way from Stratford-upon-Avon in the UK.
Thanks, Charles, for the warm welcome. And hi, everyone. I work on the internal Xbox One R&D team, focusing my efforts to bring the latest XDK features into Unity. It's a pleasure to be here and talk to you all about Unity on Xbox One.
And of course, we've always had a really great partnership with Team Xbox, so I'd like to also extend a sincere thank you to our friends over at Microsoft for inviting us to speak here today. Now, we have a lot of material to cover in a short period of time, and you'll stand to benefit the most from our talk today if you're a game developer with some Unity experience in the process of building your game, and you're thinking about porting your game to Xbox One. But even if you've never used Unity before, that's okay, because we'll be here all throughout the week and happy to answer any questions you may have. We'll begin today's talk with a quick intro on how to port your existing Unity game to Xbox One, how to take advantage of console-specific features like Xbox Live and DirectX 12, and finally, we'll close off with just a brief roadmap for the rest of 2019. Now, before we jump in, let's start off with a small reel showing some of our favorite games made with Unity, all of which are running on Microsoft's game platforms.
Here's the video.
It'd be nice to have some audio. Okay, maybe not.
So the video we've just watched truly showcases the flexibility and power of Unity. Unity allows you to bring your creativity and make it shine, and enables you to bring your ideas and easily turn them into engaging, fun experiences for gamers to enjoy. It also makes it easy to bring these experiences to Xbox One, as indeed many developers have done, just as we've seen in the video. But what are the steps in bringing your Unity project to Xbox One? Let's walk you through these. First of all, we'll assume that you have a recent version of Unity installed on your development PC. Xbox One development requires a Windows 10 PC. We'll also assume that you have Microsoft's Visual Studio installed. Version 2017 is recommended. And then you have the Visual Studio tools for Unity installed, which are available for download either in the Visual Studio Installer application or on the Visual Studio Marketplace website. The first step is to become a registered Xbox One developer and get access to the Xbox One Game Dev Partner website. Unless you have a publisher that is doing this for you, the best way is to join Microsoft's Idea at Xbox program, which you can do right here, just around the corner. This is a program that enables qualified developers of all sizes to unleash their creativity by self-publishing digital games on Xbox One. Through this program, Microsoft provides you with the tools and support needed to maximize your success on Xbox, including access to 2 development kits for you to develop and test your game on. Once you've joined ID at Xbox, you will also be able to download the Xbox One Development Kit, or XDK, which is what you need to be able to build and deploy your games on Xbox One. The current version supported on Unity is July 2018 QFE 3, but we are updating all supported versions of Unity regularly to newer versions of the XDK in order to take advantage of the latest improvements and features that Microsoft are adding, as well as ensuring that we are on an XDK version that is supported and currently valid for submission. Also, by joining the ID at Xbox program, you will also get access to the Xbox-specific part of the Unity website, including our Xbox support forums, where you can ask questions and discuss Xbox One development with other Unity users around the world. This also allows you to grab the Xbox One extension for the Unity editor, for the version of Unity they are currently using, which you should install next, as well as giving you access to Unity's native plugins for Xbox One, which we'll discuss soon. If you haven't already done so, at this point it would be a great time to connect one of the dev kits that you've received to your development PC and make sure it's all configured and ready to be used, as described in the documentation that comes with the XDK. Next time you start Unity, you should now be able to select Xbox One as your platform in the build settings window and switch to it. And you are now ready, all set to build your project for Xbox One. Have Unity deploy that build to the dev kit and then run it on the console. But how do you go forward? What does working with Unity on Xbox One feel like? And how does the development iteration cycle feel? So we have a slightly contrived example in a video now, but this will show you what working on Xbox One in Unity feels like and the steps you can take to kind of debug your game, find any problems, fix them, redeploy on the console. Right, so here we have the Unity editor, and with the project loaded, and we're going to switch our platform to Xbox One, just as I've described earlier. So once this is done, we can just build our scene and run it on the console. Right, so that's all switched to the platform, and now we can click build and deploy. And this will build your project for Xbox and also deploy that package to the console, to the dev kit. And once that's done, we can switch over to the console and have a look at it. We noticed there are a few problems with this. The camera is rotating in a weird way, and there's a wood plank in the scene there that's a pretty odd color. So as I said, slightly contrived, really simple example, but we can now switch back to the PC and fire up Visual Studio. Select Debug, attach Unity Debugger, and then we can connect to our dev kit. And at this point, once we get connected, we can do all the normal things that you'd expect to be able to do with the debugger. So we can put a breakpoint that will stop the execution of the game. And now we can drag variables into the watch window and have a look at their values and figure out what's going wrong. So if we're looking at this rotation axis, we'll try and change the value here to see if we can fix our camera rotation. And we also have this plank color variable. We'll try and change that to a different color, see if we can make it look more like wood and less like a blue plastic rod. So once that's changed, we can hit continue. Switching back to the console. This looks much better. The camera is now rotating the correct way like we want it to, and the plank of wood looks normal. So now we've identified what the problems were. We can go and change our code to do what it's supposed to do. And once we've made our changes in the code, we can go back to the editor Now, we only made code changes, so we can select the script-only build. This will only compile our C# script. It will not redeploy the assets or anything. So this makes the build much faster. And then this will copy it again on the console. And then once that's starting to run, we'll see that it looks much better, much closer to what we actually wanted to achieve. Just a quick note on the dev kit hardware. So there are two dev kit types available for developers right now, the Xbox One S and the Xbox One X, the dev kits. Through registering with ID at Xbox, you get one of each, and they're equivalent to the retail versions, but have extra features specifically tailored for development work. The Xbox One X kit also offers a mini monochrome LCD display on the front panel, which is available for devs to display anything they need to on it. Unity allows you to take advantage of this through our front panel API support. So this can be really useful for you to display performance or debug stats as your game is running on the dev kit. Once you have your project building and running on the console, it's time to tailor it for Xbox One. This means not only taking advantage of the unique hardware and software features that the platform has to offer, but also ensure that your game integrates seamlessly with the console's OS and with Xbox Live. Xbox One offers unique features that might not be available on some of the other platforms that Unity supports. So in order to give you access to these platform-specific features and APIs, we've developed and are maintaining a set of plugins. So using our native plugins, you can easily add achievement support. You can correctly associate saved games with the player's Xbox One account and have the console automatically upload and synchronize that saved game data to the player's cloud storage. Or you can build online multiplayer features. As an example, every Xbox One gamer will know what this toast animation is. It's when you unlock an achievement in the game. In order to trigger that unlocking of the achievement, and also in order to control the way the toast notification is displayed, you need to call Xbox One specific APIs. The native plugins allow you to easily do that from your game code. You just need to get a hold of your current user that's playing the game. Then you can maybe customize where on the screen that toast will be displayed in order to avoid distracting from the gameplay, for example. And then with one simple call, you can unlock the correct achievement for your user to let them know that they've just done something awesome. The Xbox One native plugins not only expose native XDKs, so they can be used from your C# code, but also provide interfaces between the XDK features and Unity features. So for example, they provide classes and APIs needed for you to make use of Unity Multiplayer, also known as UNet, with the Xbox multiplayer features, or with Xbox Integrated Multiplayer, which is a library that Microsoft provides. Or they provide functionality that simplifies implementing voice chat in your online multiplayer sessions when using Game Chat 2. By keeping these APIs in our native plugins, our engine stays as platform agnostic as possible, while also making sure that you're capable of accessing and taking full advantage of features that Xbox One has to offer. The native plugins can be accessed through our support forums, and each release comes built against the latest supported XDK with full source code and documentation, so you can inspect how they work and modify them to suit your needs if you need to. So as I mentioned before, our native plugins expose native XDK's APIs to your C# game code. So I thought it would be useful to describe via this diagram that both the Unity engine and the plugins themselves sit at the boundary between managed C# code and native C++ code, calling into the XDK directly. Our native plugins come as a set of pairs of native and managed DLLs, and all you have to do in order to use them is to copy these DLLs into your project's plugins folder. One thing to note, since we've touched on your game code being C#, is that compared to other platforms that Unity supports, on Xbox One, all your game code is compiled ahead of time. So there's no just-in-time compilation done at runtime. So just a quick note on some of the latest features. We've added support to our native plugins over the past year or so. We've added support to Microsoft's Xbox integrated multiplayer library. This is a multiplayer turnkey solution that Microsoft provides in the XDK, which vastly simplifies the creation and management of online multiplayer sessions, player joining and leaving, matchmaking, and even voice chat. Our plugin gives you access to all the native Zim library APIs, but also provides an interface which you can use to take advantage of Unity Multiplayer or UNet over Zim by using a custom transport layer. We've also added support for Microsoft's new voice chat library, Game Chat 2, and for the new Stats 2017 APIs, which replaced the older stat solution that was available in the XDK. Also keep in mind that we are always looking to add support for new APIs as they become available in the XDK. So if you notice anything missing, and let us know, and we'll make sure that everything you need is supported. Another feature we added recently, but to the engine itself, this time is support for DirectX 12 in our renderer. It brings several advantages over the older DirectX 11, including reduced driver overhead and much better use of multi-core systems like the Xbox One. DX12 also allowed us to add support for our native graphics job system and the async compute on Xbox One. And this helps reduce bottlenecks on the render thread that you might have by being able to parallelize the work on several worker threads. Going forward, DX12 will be our focus for adding improvements and new features. So the DX12 is not currently the default graphics API used in our renderer in the latest version of Unity 2018-3, but it will become that in future versions. In order to use it, you just have to go into your player settings window, and in the Xbox One tab, under other settings, you can uncheck the Auto Graphics API checkbox, then use the plus and minus buttons to add support for Xbox One Direct 3D12 to the list of graphics APIs, and then remove the support for DX11, which is simply labeled Xbox One. We highly recommend that you give our DX12 implementation a try. It can give you potential performance boosts to your game, and we've seen some great improvements when using it in our Book of the Dead demo. So if we fire that up. So this is running on DX12 now, and you can see this highly detailed geometry, which is generated using photogrammetry, is being displayed at a constant, like above 30 FPS, running at 1440p on the Xbox One X. Using DX12, we've seen over 8% FPS increase on average in our Book of the Dead demo. And it isn't just about average results either. Consistently in our demo, we see better frame rate, even in more graphically intensive areas of our scene. So I'll hand it back now to Charles to talk about the roadmap for the rest of the year.
Great, thank you, Alex. Let's quickly recap what we've talked about so far. First, Unity makes it really easy to get your game up and running on Xbox. Next, you'll want to add specific Xbox functionality, like achievements or Xbox Live Multiplayer, by using the native plugins that we built just for you. And in order to take full advantage of the powerful Xbox One hardware, don't forget to turn on DirectX 12. And most importantly, both Unity and Microsoft are committed to helping you create the best game you possibly can. We have a lot of support resources, including the Xbox support forums, XGD, and don't forget about YouTube, where we have over 2,000 videos. And looking ahead to the future, we have a lot in store for developers. First, we are fully committed to push graphics even further using DirectX 12, which we see as the future for Xbox One. When Unity 2019.1 releases soon, the lightweight render pipeline will come out of preview and be ready for production use. This render pipeline is a template in our highly customizable, scriptable render pipeline, which gives you tight control over your game's visuals. And later in the year, we'll also release a production-ready value version of the high-definition render pipeline aimed at high-end gaming PCs and powerful consoles like the Xbox One X.